Good morning, everyone. I just want to make sure the slides are, there we go, perfect. Okay, so this is a talk about Python, teaching the next generation of Python programmers. And this is a talk that uses a lot of data from the United States because that's where I live and where I went to school and where I have the best sort of personal experience. But I think a lot of the lessons and opportunities to collaborate based on what we talk about transcend national boundaries. Our journey does start in a particular state in the United States, though. This is Tennessee. Tennessee is famous for a lot of things, most notably country music and Jack Daniels. But it is also the place where I went to high school and where my family now lives. There are 285,000 high school students in Tennessee. And how many of them do you think are taking advanced placement computer science, which is the most common computer science class that high school students in the US can take? It's a national exam. Yeah, 285,000 students. How are we doing? Yeah. So we actually have an exact number. The number is 251. So less than 0.1% of high school students are taking the most common computer science exam. So with that framework, my name is Jessica. I'm a director for the Python Software Foundation. I spend a lot of time and energy and money thinking about this problem, and in particular, how the Python community can be a part of addressing this lack of engagement. So that is what we will talk about today. A few more statistics for you. First, in the United States, there is a lot of enthusiasm for students learning how to code. A lot of really important and famous and rich people, and even the President of the United States, believe very strongly that all students should have at least the opportunity to learn how to program in school. Unfortunately, reality is lagging significantly behind the enthusiasm. So this is a graph of participation in all of the advanced placement exams, so all of these national exams on a variety of subjects. And at the top, we have English language and composition. And sort of skimming down the list, we see that narrowly beating out 2D studio art is computer science, about an order of magnitude behind the most popular classes. And this lack of engagement actually hits home for me very personally, because I actually have a sister named Olivia who is in high school right now. And she is a perfect candidate for this type of class. She loves electronics. This is a picture of her soldering a radio kit. She loves math. But in her high school, she goes to a public high school in Nashville, Tennessee. The closest class that she can take to a computing class is a class that teaches her how to use Microsoft Word. And her experience is actually the typical one. Now, because of the way that education works in the US, it's decentralized throughout the states, and we don't actually have good data on engagement in non-AP computer science classes. But using AP as the benchmark, and it is the one that is most common, we know how many schools teach AP CS, and we know how many public high schools there are, so we can upper bound how likely you are to be able to take a computer science class in school. The answer is that most students simply don't have any opportunity. So these statistics are kind of a bummer, but it actually gets a lot more troubling than that. Okay, so in Tennessee, last year, 251 students took the exam, the CS exam, and 165 passed, for a pass rate of 66%, which is actually pretty normal for an AP exam. The pass rate for African American students was less than half of that. And actually, there are entire states in the United States where no African American students take the exam at all. There are states where no Hispanic students have taken the exam. And despite being 50% of the population, there are even states where no girls took the exam. And if we're going to look at these maps, we should be honest about the statistics. It may or may not be statistically significant in some of these states. There may just not be that many African American high school students in Montana. That may be true. But I think this is no real comfort to the students who represent these demographics. If I were a girl in Mississippi and I were thinking about taking a computing class, and I knew that if I took AP-CS, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be the only girl in the state to do it, I might be That does not make me feel like this is something that people like me do, or that we're supposed to do. And I damn well better pass the exam, otherwise I'm going to be a statistic that people talk about. We have gender data for all of the AP classes. And a really interesting way of looking at this data is to plot a log of the ratio. So here is that plot for all of the classes. And if it skews right, that means that there are more girls than boys taking the exam. If it skews left, that means there are more boys than girls. And this graph is really interesting for a lot of reasons. I mean, actually, if we look at this, there are more AP classes in which girls outnumber boys, right? We see at the top. But as soon as we start looking at math and science classes, it starts skewing the other way. And in fact, computer science is the most gender skewed class. And this matters to us. This matters to us because we spend an inordinate amount of time and energy and money and blood and sweat and actual tears undoing some of this inequality of representation that starts in high school and in earlier. So this absolutely matters to us. The leaky pipeline matters to us, but it actually matters to me for a lot more reasons, and I suspect it matters to you for a lot more reasons as well. You know, one reason I want students to at least have the opportunity to learn how to program, to engage in computational thinking skills, is because I understand how empowering programming is. Like, learning how to program changes the way that you think about and interact with the world. And I want more people to have that experience. I want our politicians who are making decisions about the way that my country is run to have that experience. And also, as Pythonese says, this is important to us for the long-term success of the language. It's important to us that people are learning how to program, preferably in Python. OK, well, this has been sort of a depressing introduction. And it seems like an impossibly huge and intractable problem. So what can you and I actually do in this space? Well, we can actually take heart in some of these statistics. OK, so AP Computer Science in the United States is the most gender-skewed advanced placement exam. But in Tennessee, my home state, almost a third of the test takers were actually girls. And this is the highest percentage of any state in the United States for last year. Do you want to guess why this is the case? The reason is one person. There's one teacher, her name is Jill, and she teaches computer science at an all-girls preparatory school in Chattanooga, Tennessee. And she taught almost half of the APCS test takers who were girls last year. And what this really means is that one motivated teacher can set a national record. And this is one person, and I'm looking out across the room, and I'm thinking about the people who will watch this video, and I ask an honest and earnest question, which is what can a 200,000 person community like ours that spans the globe do if we're serious about this? If we want to do something about this? Well, I asked a bunch of people, I asked a bunch of CS education researchers how they would answer this question. Like, armed with a giant Python community, what are some things that we can do to make a difference? And I'm just going to give you the fire hose of responses. I'm going to give you everything, and not all of these ideas have to resonate with you, but I hope that at least one does, and that you leave here with something that you believe that you could do. And we're going to talk in 4 big areas. So policy, student engagement, supporting teachers, and curriculum development. And first up is policy. Here's a map of the states that count computer science for something to graduate in high school. And even if you don't live in the US, you're probably in a similar situation. There is a problem that computer science is typically only an elective. And this is a problem because it does not align incentives for the people involved. If you're an enterprising high school student, you are already way too busy trying to graduate and pad out your resume so you can hopefully get a scholarship to afford college, and you're not going to waste time on some elective on some topic that you don't know anything about. And if students don't want to take it, schools don't want to offer it, and teachers definitely don't want to invest their career and training in some class that will have dubious attendance. So here's a very concrete thing that each of us in this room could do. We could pick up the phone, we could call our local legislatures, and we could call our school boards and ask for computer science to count as a math or science credit in our state. So if your state is not green, or you live outside the US, and this fact is true for you too, pick up the phone on Monday and help change this statistic. Here's another problem. There's actually not a way for people to nationally find data on what the graduation requirements are, or how teachers get credentialed to teach computer science. So if I'm a policymaker or I'm a school board member, I actually don't have a way to know if I am way behind my neighbors and I should be embarrassed. And this is a problem for the policymakers because they don't know how to fix this problem. Like, they don't know how to get this data and aggregate it and put it somewhere that would be useful. But this is fortunately something that you and I could honestly probably fix in a weekend. Like, at the sprints on Monday, we could write some Python that automates the process of aggregating this data from the various state and local sites and produce a way for policymakers to actually make good choices around these topics. So this is something that we could actually do tomorrow. Sure. Should I take this off? No, OK. Is this podium enough? Is that good? OK, great. Here's another problem. AP Computer Science is still taught in Java. And I'm not hating on Java, like, not because it's cool. Java is a great language in a lot of contexts, but Java is a problem for CS education because it is a bad language to teach in. And I'm not saying this, teachers say this. I mean, think about, if you've written a Java program, think about what goes into Hello World in Java. It is very hard to defer talking about classes, how to defer talking about object-oriented programming. It's a total nightmare if you've never written a for loop before. And actually, just quick show of hands here, taking a walk down memory lane. Did anyone here take the APCS exam in Pascal? Yeah, Pascal. Yeah, OK, some Pascal folks in the back. C++, short stint with C++. OK, Java. Cool, OK, so Java has actually been around for a long time and is getting pretty long in the tooth. And Java is a problem because it's not a great way of exciting students about programming. I mean, we have data on this because people have been gathering data on what languages colleges use, and also what languages teachers wish they were using, and what languages teachers think they will be using 10 years from now, in a compendium called Reed's List, which has been going on for decades. And Reed's List is really interesting to us as Python users, because we see that, at least in the 2012 Reed's List, Python, is still in third place. Java has a lock on first still. But if you ask teachers what they wish they were using, they all say Python. Here's another fact about Reed's List. It was actually last updated in 2012. And the reason is because the way Reed's List is gathered is that a human being calls up a bunch of other human beings and asks them about this information. And this sucks for us, because if we had the data for 2013 and 2014, we would see Python skyrocketing up that list. And this matters to us because the way that College Board, the stewarding organization behind AP, the way that they decide what language to use is based on what industry is trending towards and what teachers want. So imagine a world in which AP Computer Science were taught in Python. Imagine a world in which high school students, if they were learning how to program, they learn how to program in Python. Like, that would be an amazing world for us, for the long term, for the longevity of the language, but it would also be a more fun computing experience in high school. And this is not a pipe dream. If we got the data to College Board, this change, I think, would happen in 4 to 6 years. So if you're excited about that possibility, let's get them the data so they can make good choices. OK, so here are a couple of our policy opportunities. Next up, student engagement. And there's a really basic problem here, which is students don't know what computer science is, so they don't want to take it. And high school is almost too late for the reasons we talked about earlier. You are busy trying to graduate and get the hell out of there. So we need to engage people before then. We need to provide earlier opportunities for exposure. And you and I can do this. We do not have to invent how to do this. We can hook into a lot of existing infrastructure for engaging students about computing. Here's one great example. The Python Software Foundation sponsored a teen tech camp in Raleigh-Durham, which was run by people in this room. So a summer camp where kids learn how to program in Python on Raspberry Pis. There are groups like the Girl Scouts and Boy Scouts who have a ton of experience teaching skills to kids, right? They have the kids and they have the infrastructure. They just don't know how to program. That's the only piece of the puzzle that they need. There are tons of after-school programs where kids essentially go through modules. They're learning about art and they're learning about music, and they would love to be learning about programming as well, but they literally don't have the teachers. Like they have the computing labs and they have the students and they have the parents' excitement, but they don't have the people who know how to actually do this. So if this idea of engaging students directly is exciting to you, it's actually a very tractable problem. Just take advantage of existing infrastructure, and you can make a real difference in your local community. There are a ton of local opportunities here. So a couple of student engagement options. Number 3, supporting teachers. Here is a sad fact of life for CS teachers. If you're a computer science teacher in high school, you are probably the only one in your high school. So imagine if you went to work today and you were the only person who did what you did. And if you had a problem or you had a terrible day at work, you didn't really have anyone to talk to. If you're stuck on something, if you're working on curriculum development and you don't know what to do, you don't have anybody to talk to. This sucks. But we have a huge community. Let's bring them into it. There are a lot of really easy ways to support teachers. One simple one is to just call them up or send them an email, a local teacher, a teacher at your local high school, and say, hey, I think it's really cool that you're teaching computer science. If you have any questions about curriculum stuff, or you're stuck on a bug, or environment setups being a pain in the butt, I would love to help. Or I can even be a TA in the class, or offer to visit the class and tell the kids what it's really like to be a programmer. Bring them to the local user group. A great way to hammer out curriculum problems would be on all of us at our local Python project night. So a lot of really easy ways to support teachers, just by bringing them into the community. Number 4 is curriculum development. This is really interesting. It's a really interesting time for Python in this area. So one exciting thing is, did you know that there is a new advanced placement computer science class that is being piloted right now in the United States? It's called CS Principles, and this is really exciting to me because look at what it focuses on. It focuses on programming, but also a lot of really interesting ideas that will appeal to a much broader range of students. Pairing programming with creativity and data and the internet and how to make an impact with these skills. This seems like a really exciting way to increase engagement where the APCSA hasn't. But unfortunately, there's actually no day-to-day CS curriculum for AP computing principles in any language. And when I see a statement like this, I say, hey, this seems like a huge market opportunity for Python. Like, what if the most awesome way to teach kids this AP curriculum was in Python, everyone would use it, right? Teachers have a limited amount of time. If there is a banging curriculum that they can use off the shelf, they're going to use it. Most teachers don't have the time to invent their own curriculum on the fly. And this stuff seems so cool. Here are some examples of lesson plans from the website. Cryptography? Like, Alex Gaynor, where are you? Let's write this cryptography lesson together. Data as art? Inventing your own sorting algorithms? This is fun stuff, and we just need eyes and hands tackling this problem. And this is also something that transcends, national boundaries. There just aren't that many curricula that meet the curriculum guidelines for schools that you can use to teach programming in high school. Here's a good example of this, actually. So Think Python, my favorite introductory text, written by Alan Downey, who's probably in this room. It's great at the college level, but there are some problems with tactically deploying this in high schools, which includes that you're often in a really locked down computing environment. So one person I talked to was joking about how, in his computer lab, in addition to everything being firewalled off, even the teachers don't have the ability to install software on the machines, and then just for good measure, they would glue gun shut the USB ports, just to really lock that down. And so your only option, if this is your computing environment, is to do stuff in the browser, right? And people love Python so much that some people have created a project. It's all open source. It's online on GitHub that ports Think Python to an interactive web curriculum. Perhaps the most famous or the most used example of this right now is Sculpt, which is a JavaScript implementation of Python that is used by Coursera to teach hundreds of thousands of kids to program. But here's the thing. This is online on GitHub, and there are things that teachers want Sculpt to do that it can't do. There are open tickets on GitHub for things that they wish they could do. I'm good at fixing bugs. Whether we want this to be the case or not, it is possible that the future of teaching programming and teaching Python in schools is in the browser, so we should pay attention to that. It shouldn't be a sideline issue. So if you're into it, there are a ton of really interesting curriculum development opportunities for us specifically in the context of teaching programming to kids. So those are our 4 big areas. That is my fire hose for you. And what's kind of interesting about this is we're starting with such terrible absolute numbers and such terrible percentages that it really does mean that if you and I do one thing, it has the potential to make a significant impact on these numbers, to make a significant impact on the bottom line. And also, fortunately, we are part of a community that has this incredible network of support to help us make these changes in the world. We have the Python Software Foundation, and we will give you money, and we will connect you with people, and we will give you resources if you are willing to take that time to reach out into your community and make one of these changes. So here are a couple of ways that we can help. Run a sprint. Hey, if you are excited about fixing those Sculpt bugs, we will feed you pizza while you do it in the with your local user group. We have an outreach and education committee specifically devoted to doing this kind of outreach. If you want to run a tech camp, if you want to design curricula, we can help fund this happening. And then we also have a general grants program. So let your imagination go wild. Really, anything is possible, and we would be excited to hear from you. So OK, here's my challenge to you. Okay, we're going to be back here in this room a year from now. And my ask is do one thing. Just one thing, whatever resonated with you. If all you have time for is to call someone, do that. If you want to run a sprint, do that. If you want to help at a summer camp, do that. But do one thing. And let's report back next year and see how those numbers, see how that bottom line has changed. Here are a couple of resources for you, some classic texts on why things are the way they are, as well as, so all of the data that I've been reporting is all publicly available. So if you want to check it out and do your own analyses, you are absolutely able to do that. So this is my pitch to you. Thank you all so much for listening. If you want to talk more about this, oh, thank you. So I would love to talk with you all. I'm happy to talk about this stuff basically endlessly. So first off, I will be at the O'Reilly booth in the expo hall directly after the break, or at the break. And I would love to talk to you about this stuff. And you can also get free stuff, like free books at the booth. But I'm also happy to talk for hours and hours over dinner. So thank you so much. And I look forward to seeing what we do in the upcoming year. Horror stories, war stories, good stories?
I have a suggestion. As much as you can, involve university students, because they can help better teach young kids Python compared to teachers, maybe because they can relate to it. Also, for university students who are new to programming, the best way to learn is to teach, and it's better to start with kids. But if you involve university students, either take them to the university or get volunteers to high school. The kids can relate more to us than the teachers. So.
Okay, thank you. And this teaching the teachers problem in particular is really interesting. In the US, but also in a lot of other places. In particular, I'm thinking about the UK right now. People are starting to realize that this is important, and they're passing policies that say, hey, we got to get all these kids learning how to program. But we actually haven't figured out how to teach teachers how to teach programming at scale. So that's a whole interesting can of worms that is worth thinking about.
Thank you.
Maybe one from this side?
Hi. I kind of have something related to what he was going to say. It was more of a question. Speaking with the teachers, especially the science teachers, because science is becoming so much more interdisciplinary, and even at the university level, you see everyone needing programmers to do things for biologists, mathematicians. Did you see any of the teachers at the high school level wanting to learn how to program, and what was their feeling about that?
So I think that the state in high schools is actually pretty depressing, unfortunately, and particularly because schools don't know how to bucket computer science. Often it's in the business silo and not in the science silo, and which means that the people available to teach maybe don't super match the skill set that is required. I think lots of teachers are excited about the idea of teaching kids to program, and they're frustrated by the fact that there's no credentialing and there aren't clear classes that they can take to learn the skills that they need to actually do it. So I think they're excited, but they're frustrated by the infrastructure problems.
Thank you.
Hey, Jessica, Carol Willing. I do outreach in San Diego for the Fablab, and I have a 17-year-old and a 19-year-old. I've worked with teachers, and one of the I'm relatively new to Python in the last couple of years, and one of the super cool things, even beyond the language, which I think is so fun to program in, is the breadth of libraries, the things you can do in astronomy, music, biology. Those are things that really resonate with kids, and kids are sort of sucking up the Instructables and that kind of stuff from late elementary school on, and it seems like we've got a great community of people with a variety of interests. It would be really nice if the Python Software Foundation could somehow even just IPython notebooks on cool subjects and have sort of a clearinghouse for them, even beyond just the formal curriculum. Because I think if you touch the kid and engage the kid, they will suck it up. They're like sponges. So
I totally agree. And in particular, if a bunch of us are going to go out into schools and we want to give our best pitch for why programming is empowering and interesting, having a clearinghouse of suggestions just pre-written for us would be really useful.
First, just for my understanding, what is the base of logarithm in your ratio chart?
A 2. I think so.
2? Okay, thank you. And the actual question is, are there any efforts to, let's say, crowdsource the curriculum creating effort? Because to me, it sounds like a problem that technology can solve. Thank you.
Yeah, good question. I mean, crowdsourcing, maybe I wouldn't call it that. Certainly there are distributed efforts online that are happening for sure. And I mean, I find it incredibly encouraging that the thing that has evolved is people developing some of these tools, in the open under a permissive license on GitHub. That's actually a pretty good state of the world. So I think, yeah, collaborating on this stuff, crowdsourcing this stuff is absolutely possible. We just need the people to do it. And people who are talking to teachers while they're doing it, like doing it in a vacuum, probably wouldn't be successful. But engaging the people who will be using the content.
Hi. I come from a country called Oman in the Middle East, and over there. I'm quite privileged in terms of economic status and so on. I live here in Montreal now, but computer science is not a respected discipline in the Middle East by the people who are in the upper middle class and upwards, the decision-making, policy-making people. I was wondering if you know of any groups or projects that work towards raising awareness, because I'm pretty sure I can count on one hand or two the number of people I know who are in tech from my country. And that's a real shame, and there's such an opportunity there to get people involved, but everything here is about getting it to work in a place where it's already respected, but if it's not even respected, how do we go about that?
Yeah, that's a really good question. There are certainly resources that are somewhat US specific that I could cite. Like code.org has a lot of data and glossy material to present in a way that's very digestible to people, and some of that may translate across national boundaries. Maybe we can talk offline about more international efforts in this space.
Thank you very much.
Hi, I have two questions. The first one is, what is the role, or how do you see the role of Khan Academy or similar online kind of like universities or schools? And the second one is there any centralized curriculum or centralized project that has a definitive timeline or people dedicated to it? Because the first step of solving a problem is identifying it. I think you did a very good job of explaining what the problem is and things we could do. But I think rallying people is a good step, but we also need a good project with people that can raise hands and say, I can do this specific thing, and it might not be only centralized to this room. So what are your next steps on this rallying call? And yeah, those are my two questions.
Cool. I think Khan Academy is great, and it's great because it clearly is delivering value to a lot of students and a lot of teachers, and because it is it is one of many actors in this space of massive online learning, and that the more competition that there is there, the more we'll learn about what is effective and the better it will be. Dovetailing into the second question, I think that what folks find when they start doing this is that a lot of these initiatives are necessarily super local. So there are mailing lists for people who are interested in this stuff, and there are mailing lists for teachers interested in programming. But fundamentally, it's every school and every school district is different, and you end up meeting with the people locally who know how to make it work in that particular context. So while there are mailing lists and national and international ways to connect with people, I think that fundamentally these are problems that are solved piece by piece locally.
How are you going to track it?
I don't have a solution to this whole problem up here on the stage, but I'm sure that if there's interest in that type of project, we could think of some things.
Hey, you sort of mentioned the teaching teachers problem, and one of the actions you didn't mention was actually programmers becoming teachers. Is that something in the US, teaching sort of a notoriously difficult career, challenging? What do you think about that, of programmers actually becoming teachers?
Yeah, that's a really good question. So being a teacher is really hard, and teachers go through a ton of training to become really good at what they do, and they have a lot of experience that makes them good at what they do. If you were trained as a programmer, you definitely can be a good teacher, but there's a lot of context around teaching and pedagogy that you would have to catch up on to be as effective as you can be. So that's one aspect of things. I think teaching, developing the infrastructure so that people who are trained as teachers can become computer science teachers is probably a good idea, even if we can tap into some external resources to get teachers in. The other problem is there's an incentives problem. You have to really love teaching kids to dump your free food and $150K job to go make $40K in in an environment that is really, really tough. Yeah, so those are my 2 thoughts on that.
Hi. So I met a couple of teachers for our local high school the other day, and one of the ladies is really gung-ho, and she teaches web design, and she's awesome. And she wants to teach Python, but it's just not encouraged. So what they're doing is the person that's teaching programming at the high school is usually like one of the newest teachers, the one who's lowest on the totem pole, and they do not want to teach it. So it's somebody who comes in, knows nothing about computer science, knows nothing about programming, and could really care less. And so right now there's a woman teaching, and her comment the other day was that she really didn't care about it, and that there were a lot of girls in the class, and she said women shouldn't be programmers anyway. So I'm just very frustrated. It's, Charleston, South Carolina, I mean, it's, a little backwards, but it's very frustrating to hear that, and, there's some people that are setting us back, and it's actually some of the women are setting the women back, and I don't get it. I don't know what to do. I don't know what to do with that.
The change is going to be slow. It's going to be incremental, but it will definitely happen. If we put our collective efforts together, we will converge on the thing we want to see here. I definitely believe that.
Hey, I just wanted to shout out one more organization, one that I don't think I heard you mention. Black Girls Code is in a few big cities across the country. I volunteered with them. When you show up, you only need to commit to a single day. It's usually a Saturday, 8 hours. And the experience that you have with those middle school girls doesn't at all reflect what's in the presentation. They're excited, they're engaged, they learn quickly, and it's a wonderful thing to do. So if you've got a free Saturday and they're in your area, or if you want to bring them to your area, I strongly encourage you to make it happen.
Awesome, cool. And yeah, again, that early engagement is so critical.
So I don't really have a question. I'm going to hijack the mic here for a minute to make an announcement. I had the privilege of seeing an alpha version of this talk down at Tennessee, and as a result of some conversation that I had with some people there after that, I was back down in Nashville 2 weeks later for a workshop called Click. The idea behind Click was to put 50 working software developers and 50 teachers in a room together, let them give lightning talks, tell stories, talk about problems and solutions, and then spend the afternoon coding a project together in Scratch, just as a way of starting to develop those teacher support relationships that Jessica was talking about. So I'm actually one of the organizers of CoPy in Columbus, the local Python user group, along with a number of other SIGs in Central Ohio. We are going to do Click Columbus in first quarter of 2015. If anybody is in the room from Ohio and you want to get involved, we're in the very early stages of planning this. I'm the guy wandering around the conference wearing the PyOhio t-shirt. Find me. Thank you.
Awesome. And this sounds like a model that could definitely be replicated in other cities, so that's great. Maybe last question? I don't know. Yeah.
Several years ago, maybe 5 or 7, I actually contacted my old high school programming teacher and gave him an open-ended kind of, what can I do to help with bringing up kind of the level of the game here? I'm very involved in the local geek community and would love to help. And he kind of gave me a, well, I'll get back to you, and never did. And kind of, that was it. So do you have any kind of pointers for, all right, well, I really want to help my local community. How do I crack that nut? How do I get in there and get to the people who may be willing to engage with the local community to bring in that help to make it happen. Do you have any thoughts on that?
Yeah, teachers are in a tough spot. They are teaching they're in the trenches every day, and they don't have that very much time to plan outside of when they're actually teaching. And I think that to the extent that you can give specific actions that you can take, it's harder for them to sort of consider the options and get back to you. If you say, hey, I noticed that all of your students are dudes, I would like to help fix that by recruiting from these other spaces, they might be really receptive about that concrete idea. Or saying, hey, I'm available on these days in the next 2 weeks to come talk about programming with your kids, would that be interesting? So I think specific actions are the best way to appeal to teachers who are super hosed all the time. And then there's teachers, but there's also, the schools and the school boards. There are sort of lots of pieces within the local community that can be engaged around sort of specific actions. And again, that phone call to your local legislator, your local school board saying, hey, please make this count as math or science credit is another example of a very specific, concrete action.
Thanks.
Thank you. Are we? Okay, thank you. Thank you all so much. Come find me in the expo hall.